Hi guys, welcome to part 12, I believe, of Formatables Refactor. So we were already doing some work, so let's just clock probably from 1350, I think. So where were we then? We were trying to figure out how to add the artifact over to, the technical space to the artifact. But really, we should begin by looking at how this is being co-generated. So at the moment we have the notion of a technical space. So we did a quick hack for this, which was, in order to generate the template, we created a method called major technical space area. So every physical element has a major technical space. Now this is not really correct. For starters, we had it on facets, physical element. So I don't think this is the right modeling for this really. Make sure we're recording. And we are. So the major technical space at present, as far as I'm aware, is used only for this hack here, for the headers. And we use it to determine whether in C++ or C#. But really, the right modeling for all of this is to say that archetypes have a technical space and backends have a major technical space and then minor technical spaces. So we don't really necessarily need that right now, but we do need a way to say that archetypes have a technical space. And then the second problem is that we then need to populate the template. So we must be, so if we have a quick look at how an archetype looks like, this will be the factory. We should see somewhere around here. Yeah, so there's no reference to technical space whatsoever, which is what we'd expect. The reason being that, of course, we don't really need the technical space for anything other than code generation. Now we need to put it on the meta model. The second problem is going to be that we're going to have a lot of elements which have distinct technical spaces. I think we could probably get away by populating them at a very high level, such as here. And I think that probably will do. Right, so let's just go for that then. What we'll do then is we will update a few things here. First, let's clean up the way that this is implemented originally. Let's just not add it to every single element and add it just to the archetype. And I think we should probably just actually, one thing that's not clear to me is how exactly is this major technical space being populated. Let's have a quick look by going up to RG and then doing a quick grep. So there's the major technical space. That's the use of it. And here's the place, I think, where it's getting populated. So we seem to be taking the major technical space in the back end. And the question then is, how does the backend get it? And what we do then is we must have a feature, major technical space, which we probably populate at the backend level. So around here somewhere we should see major technical space. There we are. So we need something equivalent to this. We need the technical space. So the technical space will be applicable to backends, not applicable to facets, and we can just capture the minor technical space. I mean, we don't have a use case for it yet, so we'll leave the minor for now. But if we just have technical spaces, I think that would do. So let's go for it then. So physical model. around here somewhere we should see major technical space, and that would be presumably I can't actually see technical space here, interestingly enough. That is most peculiar. You would have thought the feature would be defined in the physical model. We must have made a mistake somewhere. So let's go back to the backend. The name of the feature is MASD.physical, major technical space, so clearly it must be in the physical model. There's no feature bundle that's obviously named after it. And I can't really see it anywhere sensible. So the only other possibility is that we did a hack and we added it somewhere else. What we'll do is we will just quickly go up to the models and rerun our grep, and hopefully this will give us a clue. Seems like we defined it in the logical model for whatever reason. That is quite a funny place to put it, given it's a physical feature. Let's have a look. There's a lot of features in this model, sadly, so it's going to take us a little while to find things. To find our bearings. Oh, okay, actually the reason why is, no, okay, it does make sense to be in the physical model. The reason why in the logical model, it's a logical feature in the sense that we read it for the purposes of the logical model, for the purposes of populating the logical model. So that kind of makes sense. So we probably should keep this. I mean, it sounds a bit confusing, but it actually kind of makes sense in the craziness that is our code base. So what we'll do is we will copy exactly what we've done for the major technical space, and technical space which this element belongs to. Okay, so I think we probably should just put it next to the major technical space. Alright, so now then we have a feature just for technical spaces. And then what we'll do as well is we will add that to the archetype. Now notice that we're not adding it to all the elements. Though to be fair, we should have it in the back end and on the archetype. The reason being that the back end has a technical space, the archetype has a technical space. Archetype kinds, facets, and parts don't really have technical spaces. They can contain multiple technical spaces, but they don't really have a technical space associated with it. So perhaps what we can do is we can follow on from that template that we created over there and create a new one. So maybe about 3 of these spaces, I think. And perhaps a bit more, I should think. So create a bit of space here at the top, and then we were to just add another chap here. Actually, we should look at the color scheme. So E3E. So so I never quite know what to call these templates. So we're just going to go with that. To be honest, it's more like so it exists or contain, oh no, represents, well, I'm just going to leave it as it doesn't really matter because we don't, I mean, of course we want the names to be clear, but these names don't really have a lot of meaning other than the modeling level, so right, so this is probably alright. And then what we can say then is we can say, well, we like archetypes. and backends to have technical spaces, right? And for good measure, go to the physical model. As you can imagine, we're just going transversely across all the elements that need this. So in the physical model, we'll have similarly a need for the same templates. And I'll explain in a second how we've gone across the stack. So this guy here. It has a type and a comment. And there we go. So just to recap what we just did here. Oh, actually no, let's just finish the job because we still have to apply the template. So in order to apply the template, we need to do similarly find the elements that we're interested in. Which are these two guys. Alright, so now what have we done then? So what we've done is the following. We said first we need to represent at the logical level. Well, actually, to start off with, we need to first represent the feature because we need to read information for this. Right, I might be able to make this a little bit more sensible. It would be nice to not to take so much space with this. This is the annoying thing about having UI. So as I said, what we need to do is we need to first represent this as a feature because we need to read metadata. So we've done that here in the physical where we add technical space as a feature. That then allows us to apply this feature to the backends, as you can see here for magical technical space, but also to the archetypes. Then what we'll have to do is we'll have to update that the reading of the feature to populate the types. Then we added the feature, well, we added the field to each of the types via a template, which means that when we read the logical model, the archetypes in the backend will now have access to the data in the model. Then these guys here are used to co-generate, and they will co-generate via the templates, which we'll have to update in a second. And then what we then done is with the physical model representation, a physical meta model representation, then we'll contain this new property. And so this is more or less the complete stack when it's making a change across Dogen that involves code generation at the meta model level. So that's cool. So I think we can just generate this for now. I mean, we should probably make sure that we are running with latest. And then hopefully we can generate all models. Now we then change this to logical and physical, I believe, so we'll have to convert logical and physical. And of course, once we convert, we have to indent as well. And if I have a quick look at what the changes look like, one would expect to see a whole lot of new types, I should think, and then hopefully we can run the tests against this. Nothing major should break. Got a lot of changes because we are touching physical and logical elements, which are at the core of the system. So we're going to have to wait for a while. Let's see the cosmetic changes while we wait. Permanent feature of having UIs. So what the feature for we do find UML diagrams, to be fair, to be quite useful because it's a very easy way to visualize things. But it's better to generate the UML diagrams on demand than it is to have to maintain the UML diagram. Because if you've been following this series, you've already seen how painful it is to try to get a diagram in a sort of a sensible state. It is quite a lot of work, and it's particularly for people that are sort of OCD and start to struggle when lines are not straight and things like that. So what we really want is to have a program, a bit like Clang Format, but that basically takes away all the faffing around with the indentation. You kind of need a way to generate a diagram that doesn't really require a lot of touches, and it just generates a diagram. So we're 15 minutes into it, and still got a fair amount of work. So our objective today will be to see if we can, if I go back to what we wrote for this, what we're trying to do at the moment is we're trying to basically implement this very first use case, which is to see, in fact this guy here, to check what the technical space is before we can add the build, the header. So hopefully we will get to implement a few of these. I'm hoping this is actually the most complicated case. Of course it probably won't be, but there we are. So that's all looking quite good. Now then, so if I just say logical, physical, add technical spaces to RQ types and backends. Right, now then, so these are probably just cosmetic changes we've done to the physical model. It's good to get rid of all the changes, so we start with a clean slate. Now then, now what we need to do is we need to read the property if available, and we were already in the right place, if I remember. This guy here, and we more or less have got everything we need. So I think what we need to do is to say we will remove major technical space in a second. So if we just say something like technical space it is a bit annoying that backends do have a major and a minor technical spaces, but fine, we just leave it like that. So what we're doing here is we're reading the technical space, and let's write out some configuration. This just seems like LSP is a bit upset at the moment. Okay, so if I just do a direct jump, it's a lot of upsetness and Emacs at the moment. Right, there's our direct jump, so I'm just going to kill this guy and restart it to see if LSP is slightly happier. Right, so what we're trying to do then, we're trying to say that we read the technical space. Do a refresh on Emacs as well. Right, as you can see here, we read the technical space from the feature and populated the backend. That's fine, no worries. Now then, similarly, the artifact will probably have something like this. Yeah, the archetype, I keep saying artifact, but whatever it means, archetype. And then in here, one can don't particularly think there's any right place to do this. Right, so I suspect around here reads the technical space, and we are missing something here, I think. Right, so I'm just going to be a bit lazy. We're using this in multiple places. It seems to me we don't really need to multiple usings. Now then, right, so the idea then is that we read the technical space from the configuration, we remember what it was, and we populate it. But now, presumably, not quite sure what the variable we're using for archetype is. Perhaps arc. So we're not confused with artifact, which we normally say A. Okay, so that doesn't look too bad. Minus a few bugs there. Okay, cool. Now let's populate in the technical space for both backends and archetypes. One thing we did not do is we assume that there shall be a technical space. Now, if we do this, we will break everything, I think, because we don't have technical spaces just yet. So let's think about this for a second. We need somehow very quickly to go to every single archetype and add a technical space for it, and then we will have to in fact, to be honest, this is probably fine because I think this is only going to kick in when we're processing the text C++ and text or C# models. So I think we can probably do that. We'll try it at any rate. So what we need to do then is we need something like this. It's a shame we can't search it, can't copy and paste, but there you go. So here we'll just do something like mas.physical.technical space, and that's of course C++, and this space presumably. And okay, we have mismatch here. Let's be addressed some other time. Now then, so in here what we'll do is we'll say, well, all the headers clearly all belong to mas.physical.technical space CPP. Clearly. But notice that not all archetypes, although having said that, I don't think anyone is using the base archetype configuration really. Let's have a look at this. Let's do something like, say, symmetric lists. And yeah, as you can see, I think by base archetype, this is a very misleading name really. This is basically basic C++ archetype really. So what we'll do is just be lazy and say actually both of these guys have that, and then that saves us from having to do it to this level. Right, now then, that means that everything to do C++ and header files and C++ implementation files is taken care of. And now we just have to look at the odd one outs, whatever is missing. And these guys will be actually, well, now this is where we have to be slightly careful. We have to make sure that when we go to the logical model, well, to be honest, the identification model, and look for technical spaces, they match. So CMake, and this is one of the problems I think of this kind of work, is that it is, part of it is quick refactor, let's get on with it. Part of it actually is model things correctly. So we could of course do some quick hack for this, but this bit of code is actually relevant to the future. We are modeling things correctly. No, what's going on here? Can't see. Ah, there we go. So these are ODB, correct? So they're in the right technical space now, and then CMake. In the future, technical spaces will themselves be dynamic, so update driven, should I say. So Oh, actually, I wonder what these guys will be. XML, clearly. This is another interesting thing where we may have more than one technical space actually. For example, in this particular case, clearly this is XML, but there's a specific XML type. So perhaps we should really have a technical space, or perhaps we should have an associated XML schema, I guess, because there's clearly a type. Right, okay, that's those guys. I think logicless template, that will be mustache. Aha, we don't have one for those, so well, that should really be mustache, because these are the templates that we have for those. Just let that be for a second. So do we have any comments here? Mustache templates. That's probably enough. Right, so in this case, what we'll need to do first, as always, generate everything. Don't think we can generate everything actually, so let's just do a generate identification Dogen dot identification dot dia. And also we need to convert to JSON. We need to indent the JSON outputs. And what we'll do is we will make sure so this probably will not work because of this transform. So let's just do a quick hack over here in the transform. I think if we comment out this bit here, if we comment out these two bits here for now, just because I don't really like committing without running tests, and hopefully this will give us the greenery that we need. Going a bit slowly, so that's the part of half an hour already. Machine seems to be slowing down as well. Sadly we just changed technical space, which is probably one of the most central types, so that's going to take us the old time. Right, so now then, whilst that's doing its thing, I think we just need to continue our work. So what we need to do then is we need to now say something similar in C# world. So hopefully here we will have base type, and then what we need to do is to catch anything that's not covered by that base type, which maybe it's just these two guys here, I think. So in these cases we just need to say something like no, actually what I meant was XML clearly. And of course one of the things you probably have noticed already is why is it that we model solutions in both C# and C++. It doesn't really make a lot of sense because the modeling of solutions shouldn't be dependent on technical space. This is something that we haven't actually resolved yet. See how we're doing here. Halfway through, a third maybe. Okay, I think we covered everything. Let's just make sure we didn't miss anything. So all these guys are going to be C++. Main is clearly C++. All these guys are C++. These guys here are not, but they're CMake. That's done correctly. These guys are all C++. These are C++. These are not, but they should be done correctly. These are all C++. Okay, done correctly as well. And then the templates, which we sure we done mustache. Ah, good spot. Seems like we did mustache, but forgot to actually add it. Which is fine. And then we have C++ and a load of C++. These are all going to be XML. And then finally C++. So I think with a bit of luck, we are done. Right, so compiler is taking his time. This sort of set cases is worthwhile having a look and seeing what else we could be doing. So we in our legacy dependencies, what we'll do is we will actually, this one thing we're missing is we're missing the bit where we write down over to the CS template updates. So that's fine. It should not stop us from committing now, I think. So tests passed, as you'd expect. Actually using the latest code generator. And so we basically, we could say something like add technical space for mustache. And now we will return to this guy here. So now what we'd expect to see now is something like no errors, no throwing when we do generate all types. First thing, when we run all tests, we shouldn't expect any breaks. It probably will break actually, because I think we need to regenerate the C# models, or the JSON models, I should think. So we may have half of the tests failing if there's a test for JSON text.cpp, text.c#. So a couple of fails. And in gen, here we go. And as expected, oh, actually interesting. Dia, well, JSON is expected, but we had a break in Dia. Now that is slightly puzzling. One of the types we chose was not right, so most likely not. It's going to be mustache, being the odd one out. Mustache. That looks right. Interesting enough, we have SLN. Okay, we made a mistake, modeling mistake. Solution should be in SLN, not XML. So that doesn't explain the problem, to be fair, but that's XML, so that should be correct. And then similarly, because of course Visual Studio Solutions are not XML, it's correct. Now, what is causing this break, one wonders? It is quite annoying that exception doesn't tell us what is throwing. But nonetheless, we know it's in C#. So that would tell us that really there's not many options here in C#. So the XML, well, we know that's not the case. So clearly has to be this guy here, which funny enough is wrong, should have been C#. Why did that fail? That looks perfectly sensible actually. Why would C# be failing? Maybe we forgot to do one of these. See if there's any type here which it does not have. So object configuration, section configuration, button configuration, enumeration, primitive. So all these are inheriting from a configuration. So are these. So are these. And these two are not, but they're the right types. Oh, okay. We're still broken C#. That is very puzzling. It is as if one of these guys is not supplying. Make sure that all of these guys are really inheriting correctly. It looks sound. Okay, well, that's why we have logging, so... I mean, of course, it would be nice if the exception told you which type is failing on, but there you are. Not everything is perfect around here. So if I just have a look at code generation test, perhaps... perhaps not. Feasibility tests. Okay, this is annoying me now. I wonder if I can just do a L workspace find symbol. Ah, nice. That seems to be taking me to a test. Okay, and then of course tests always slow down because of the amount of entries you have in the test. LSP gets a little bit unhappy. So, and if you can't type, that does not help. Alright, so that should give us a bit of logging. Whilst that's doing its thing, we shall go up to the log and so we were probably in physical model generation test, perhaps. I'm not entirely sure what test we were on. So we were in the... Yes, I was right. Physical model. Max slowing down again. So we are in the physical model production chain. What is the test suite? It's a shame that it's so slow. I think it's actually Tremax that slows everything down, rather than LSP. But slow down it does. So we are in the right load. Physical model production chain tests. And so we would have thought that around here, there we are. And in here we should have 244. It's looking very green, sadly. 1444, that sounds about right. I wonder if we're not even logging. Yeah, sadly, I think, yeah, this is very unfortunate. This is bypassing logging, actually. This is directly the lexical cost that we're getting from Boost. It's probably not a good idea. We should have a wraparound this. Ensure that we do some logging. That's not really very good. I think all that's happening here, it's a bit confusing, but all that's happening is, this is where time gets wasted quite a lot. All that is happening is that when we're processing this, we are probably... okay, the good thing is we're at least attempting to write the technical space. So although it's not an error, it should be in the log file. So if I look for technical space, here we go, it's blank. Okay, cool. So as you can see here, we do not have technical space for MASD and actually, silly really, this was quite a very basic error. We forgot to add it to the backend. Right, so that's the first problem. The second problem is those errors were absolutely atrocious, so really what we want to do is to say something like if this guy is empty, throw a nice exception. But really it doesn't make sense to create one of these guys. Okay, I think I hear some noises downstairs. Okay, situation resolved. So what we're saying then is we don't expect the space to be missing. So let's just make sure we check for that. And then we copy that idea across. And we're not going to bother doing the same thing for oh, actually I can already see this was not the best way. We should have gone with that guy instead. Okay. And then we could just say something like expected technical Emacs is not behaving at the moment. So expected technical space to be supplied. Right, so now then we could just do this and quick fix to this guy here. Right, now then what we'll do is we will, I still don't like the notion that we are not supplying. It's going to be a bit too much trouble for myself, I guess. So this is going to throw, hopefully, slightly more sensible exception. While that's doing his thing, we could just go to the test again. So that would have been test.cpp, physical model. And just so we don't forget, remove the debug from here. Right, now then, quite a few errors coming through, which is what you'd expect. These errors are a bit more sensible. It's quite annoying when Emacs starts slowing down like this because it's not really sure why, and I'm not very good at the profiling. Right, here we go. So that looks good to me. Now then, what we intend to do is to go back to where we were. See how much the undo take us. So we just add this guy here. We don't really care about the logging now. And this should now take us to 2 failed tests, which will be the JSON tests. Once that's the case, we should be able to just do a conversion. Okay, 2 failed tests as expected. We will just convert these chaps and indent them. Now, at this point, we would expect the tests to pass. Nothing particularly special is going to be happening, as you'd imagine, because we're not actually doing anything with the new stuff. But we want the test to pass. Okay, which is very good. So we could say something like read technical space. So logical read technical space feature for archetype and backend. Okay. So at this point we are now reading the feature and it's being populated into our logical representation of the physical model. And now the slightly harder work starts, which is we need to update the generation of the elements, which is, I believe, already what we've got in our template, but for good measure we'll just grab it anyway. If we have a quick look at templates, what we need is to just basically say around here somewhere, perhaps, we have a lot of stuff going on here. Just going to put it at the top, no particular reason, r.technical space, and this is going to be equal to, and now you have to remember that we're reading an archetype, so I would just say the archetype's technical space, and we also need to bear in mind that we are trying to initialize an enumeration. So that enumeration would be something like identification, entities, technical space, and then whatever value. And we know for sure that should be a value here. So that should hopefully update the archetypes templates. And then similarly, we should be able to do something very, very similar. Didn't quite grab what we should have grabbed. And what we need for this chap here backend class implementation factory. Sorry, I think we got a bit lost here. So archetype class implementation factory. This is used by every single archetype. Oh yes, and backend is also an archetype. So perhaps we only have to update one. So this sadly, when we are doing meta model work, it's really a bit mind-bending. Always requires a few goes. So let's just try to generate this. Probably are not running from the latest code generator, to be fair. So what does that give us? Okay, so now if we generate a new code generator, and then, okay, okay. So, okay, we made a classic mistake. Right, okay, cool. I know exactly what we've done wrong here. Sadly, this is going to take a while to fix. What we've done wrong is we keep forgetting where we are in terms of the hierarchy, and what happens is the logical representation of the physical model doesn't really require hardcore domain types. What it requires instead, so what we'll do is for this guy here is let's just do a quick stash. So what the logical representation of the physical model requires is something that's ready for code generation, which means we don't really need an enum. We need a std string, and this is correct. It looks like it's incorrect, but it's actually correct. And then, because remember, this is not a real domain type. This is a type that's used only to generate code. So really, for these cases, you don't necessarily need a top level real true domain type. What you need instead is you need a thing that you're going to slot into the template. So I ended up creating an enumeration, which sounds very clever, but then you have to then convert the enumeration back to a string. And that's not what you want. So let's now then just do a quick regeneration of this. And let's get our logical model into shape. Right, so hopefully this will give us what we're looking for. worlds. Okay, now of course what we're gonna have is all that stuff that we just did a second ago with lexical casts goes away. Now we still need whatever nonsense we had there before, but we don't need all of that stuff. Just need you to slot the guy in there, just a string. And this guy here, very similarly, no particular cleverness. Just copy the string across as you read it. We probably should have some validation really, but I mean, in the real world we would say something like, is this really a valid technical space? In fact, to be honest, one thing we probably want to do is to have a method in our enumeration that enables us to know if a string is a valid enumeration. Let's just write some story quickly. Is add method to check if string is valid enum. We have a method to convert a string to an enum, but sometimes we just want to know if it's valid without converting. We should have a method that just returns true or false or throws if the string is not a valid enum. Right, we can easily do this because we already done all the hard work for this, so it makes no sense to have to do this by hand. Right, fine, there we are. Okay, that's all good. We now have a code generator that vaguely does the right things, and then if you go back to Git and we say something like logical make a technical space string in backend and archetype, we can quite easily now go back to where we were. Not quite sure why. Let's try to stash this guy. I wonder if we made a mistake somewhere. Right, that's good. That's perfectly fine too. I'm not entirely sure what this guy is complaining about. Sometimes Git, not sure if it's my Git or Git, but it gets into a bit of a state. So clearly the story is open here as you'd expect. Don't really want to waste too much time with this, so I'm just going to be lazy and I wonder if I can actually just say, yeah, it's not diff mode sadly. So what we'll do is do the lazy thing. Not so lazy I guess, but let's just apply this change. It's annoying. Now let's get rid of our stash. We don't need that anymore. Okay, cool. So now we could regenerate this guy. Okay, now that's it's probably not going to be a big problem. And then, as we did a second ago, need a few conversions. Let's make sure there's no one trying to talk to us. Nothing too much. Good, as expected. And finally, you can just drop a few guys here. Oh, interesting. I thought we generated, perhaps what we forgot to do is we forgot to, no, what we've done wrong here, this is a classic case. So what we've done wrong is we forgot to regenerate the code generator and then regenerate the code generator after that, because we now have a new code generator, as you can see here. That code generator is now generating very different code. Clearly that's what we're looking for. And now you can clearly see here that we made a mistake. We left a quote where we shouldn't have. No problems. So let's just then make sure we got everything we want, which is these guys here. And then let's select everything here. Let's call this temp. We don't really sorry. We don't really care about that. We care about these though. Now let's go back to that lovely template of ours, which is this guy here, and you see that there's that thing there in the wrong place. So what we need to do is to say this will of course all be much easier in text mode. So let's go to this guy, obtain the templates, unpack it here, and where we say is an enumeration. So identification, entities, technical space, and then finally the actual technical space itself. That looks good. Okay. And sadly now we have to go through the whole process all over again. In other words, we need to update JSON. Regenerate the code generator. Make sure this does not have quotes. Oh, I still see a quote where I shouldn't have expected one. I think the problem with this now is going to be, if I look for class implementation factory, there's quite a few of these, of course. Actually, it's going to be two. This is too complicated. I could do this properly, but sometimes you can't be bothered. And the right thing to do here, you see, this is correct. We just need to pick up this guy here, and then stage that. Now we can't actually compile. And so we need to yet again stash and unstash a whole lot of things. And so we just need to apply this guy. And now we discard these two. And then if we could just regenerate the code generator. And then regenerate the models. If luck is on our side, we now have the correct code generator. So this is the latest code generator. It's going to regenerate the code generator, and then a whole lot of stuff comes through. And now you see this is correct. And then if I just regenerate the code generator again, the code generator will now generate a code generator. Well, the code generator that has now been generated will contain a code generator, which correctly instantiates the physical model. And that's what we were looking for all this time. So now then. Clearly we need to commit all these things in one go, because otherwise we'll break. We forgot to run the tests. And this bootstrapping process is the process that sadly is just a little bit tricky to get in your head, because we're using the code generator to generate the code generator. So every so often we get lost a bit in the loop. But it's, once you get the hang of it, it's actually not too bad. So we can now say something like text.cpp C# populate technical space for archetypes. We haven't done that for backends though, so I'm not sure what would. I'm not entirely sure what would happen there, but we don't really need to worry about that just yet. Okay, doc. So now then, where are we then? So now at this point in time, we should have an archetype that contains a technical space. However, we're not quite out of the woods yet. So the archetypes in the backends have technical spaces, but it's not the only guys that need it. The artifact needs it as well. So what we now need to do is we then need to say something like, please add that to the artifact, the first step, and should we memorize some of these targets. It's a bit painful having to remember this. I typed this by hand. Usual laziness. Sorry, what I really meant to do is to say event. Right, now then, nothing major will happen here, as you can imagine. All you expect is to see this thing generating. Sadly, it's a lot of, it touched a lot of files. As you can imagine, artifact is used by a lot of things. So now, what's happening then is that you can imagine where we've been doing now. We've been going from the logical model to the code that gets generated from that logical model, to the physical meta model, and then from the physical meta model to the actual instances of the physical meta model, which are the artifacts. So what we need to then do is to say, when you instantiate an artifact, inherit the technical space from its meta type. And we probably, while we wait, we could probably do that. That's going to be something like the projector, presumably. And around here, we're going to have something like, interesting. We have the physical meta names. We really wanted the archetypes, so see how we got these physical meta names. I think we went to the index. This is not ideal. Yes, so we are not actually reading the meta types themselves. We're just going through the meta names. Let's see if there's any other transform. I think our configuration is finished. So for the purposes of our transform, we didn't need to access the meta types, the physical meta types. It's a bit annoying. See if there's anything else that could require that. I mean, clearly we're going to need that for relationships. But we haven't really gone very far with that transform just yet. So it's let's just commit this first. Add technical space to artifact. Okay. Now then, are we going to populate this? Sadly, the projector, which will be the right guy, is working off an index. Now, of course, you'll say there's nothing stopping us from querying the meta model, the physical meta model, of course, and looking for the archetype for this artifact. After all, we got the meta name, so the only slight problem with that is that we don't really have an easy way to query the entire meta model. We've had this problem a few videos ago. I think we resolved that for the specific problem we had, which didn't really require the lookup. However, this time I don't think we can get away with it. Because in order to locate this particular archetype, we need to know what backend it's in. And then in that backend, we probably need to know what facet it's in. And then that's where we'll be able to access it. Bit of a shame, really. This is quite a tricky thing to do. Alternatively, we could say that there is an index of meta name per technical space, and then we could just access that index. This is the annoying thing. Sometimes you just want to do something absolutely trivial that should take you 5 seconds, and then before you know it, you need to re-engineer the whole model. Well, I think what is quite clear here is that this is a general problem. Let's just think about this for a second, and sadly this is the job, really. This is the ask. Okay, we have looked at the archetype names by logical meta name. Part of me now starts to say, actually, what is the point of having a meta model that is indexed by an order that we don't particularly care about? So why don't we have a container of archetype by meta name, for example? At the moment we don't really have a pointer of archetype, so we don't have to make a copy of it. A bit annoying, but clearly this is going to be a problem in the future. It's also a bit annoying that we I wonder why we need this to be indexed by logical meta name. Ah yes, the reason why it needs to be indexed by logical meta name is because not all archetypes, so as you're processing each logical model element, as you can imagine, this thing is going to process logical model elements. So the expansion of the physical space comes via, so these are regions in the physical space. The part of the region is anchored in the logical model element, and then in the dimension, the physical dimension, then you have the whole of all the artifacts, all the archetypes. And so the problem at the moment is that we do need this indexing, because we don't really care about every single archetype. We care only about those that belong to the right logical meta element ID. So if we don't use the index, we then have to filter the archetypes on the back of the logical meta model, logical meta element, the logical element ID even, which would not be ideal. That's the job that's already made for us by relying on the index. So then, what are we doing for time? About an hour and 10. Not entirely sure what we should do here, really. We just need a quick way to determine for a given artifact what its technical space should be. Presumably, the vast majority of artifacts are going to be C++ or C#, which is the backend type. So, the noise outside. So, let's think about this. Maybe we should just go for the easy solution. We could just have archetype names by technical space, or technical space for archetype. Yeah, I'm afraid I'm just going to take the easy way out here, because otherwise we could spend a long time here trying to debate the right things to do, and we don't have the time for that. So we could have something like technical space for archetype name, which is very, very simple. It's not very nice, but and then its type is just going to basically be technical space, and then it's going to be a stud. No, actually we're doing the wrong way around actually. So what we really want is to say physical meta ID for technical space. So if you give me physical meta ID, resolves given physical meta model element ID into its technical space. So technical space for archetype name. No, archetype ID presumably. Well, to be honest, I'll just call it for archetype. Technical space for archetype, right? So here we are. We may need a bit more space here. So not very pretty, but it does the job. Technical space for archetype. So given a physical meta ID, I'll tell you what this technical space is. Now, yet again, we have to go for some more code generation. And if we just convert the identification model to JSON, and if we just indent it. Right, so this will then give us the container that we need. Which is nice. Something not right with our logs. Right then, so if I then run all tests, I mean nothing major is going to come from here, we're just going to generate the right indices, and the thing to do then is to look for whoever generates the physical metadata indices. Don't think we have a transform for this here. Or a helper. So it must be the responsibility of somebody in the physical model to do the population. So this all looks green. Just going to move away from this file. Make sure we got latest code generator. Righty, so then add index for technical space for archetype. Add technical space for archetype index. Okay, so now we have that index there. Let's see who would be responsible for populating the indices. So I'd say something like physical model, meta model transforms, compute name indices. So our Helm workspace symbol, compute something like this. Compute name indices. Sometimes the Elm workspace is not quite as good as just a plain find file. Right, now then, so what have we got here? Update physical meta name, logical meta name. Right, let's just create a simple indexer. Indexes, archetypes. But so indexes technical spaces for archetype. And the return type of this guy would be something like whatever this guy is saying. The dive seems to be slowing down a bit. Beefy machine, not sure why it's so slow at the moment. Guess we are working it hard. Probably should keep an eye on what's consuming all these resources. Right then, so if we just say give me physical meta ID, clearly there's space too many in here. So if we just do that, and then I don't know whatever the name of that method is, obtain. I don't really, these names are all a little bit fudged, but there you go. So give me a meta model. I know it's a physical meta model because we're in physical land. And what we'll do here is we'll probably make this static. And what we'll do here is we'll say something like this, right? So it's all going to be very similar to whatever else we've done already. So I'm not even going to bother thinking. And say we obtain an archetype. Oops, almost like we're programming in Lisp here. Okay, so we need a return type. We need to return that guy. And then if you could just do something as simple as r dot insert arch dot name, meta name dot id. Of course, you know, we can't just insert. So if I just do something, oh, actually notice that we went for non-const. There's no need for things to be non-const here. So if I create a pair, I actually don't need to do that. So stud make pair of the name to the technical space. Now, if you can see, we already are struggling with space, so const auto ID is whatever that is. Const auto technical space is whatever the technical space is, id.ts, and then if you could just do something as simple as const auto inserted, insert the pair, make sure it did get inserted. This is all boilerplate code that we really should be generating, but there you are. Such is life. Clearly very much copy and paste. Always a sign that you should be using the code generator. And the archetype is going to be something like the ID value. And now then, what are we doing here? So stud make pair. Const auto pair. Right, okay, cool. So as you can see here, something very trivial. What do? We just basically iterate through everything in the meta model, in the physical meta model, and we look for the backends, facets, and the archetypes in those facets. For each facet we obtain the archetype. For each archetype we take its ID in technical space. We create a pair with the ID in the technical space. We slot that in our container, we return it. And here we can do something as simple as finally index archetypes by technical spaces my archetype. Okay, we can just call that whatever I call that. Space for archetype. And that should just be whatever the current state of the meta model is. And then we just do the meta model dot indexed names Dot technical space for archetype. That's that guy. And hopefully, if it all's gone well, we have done our job. So at this point in time, we'd expect to be able to have an index that's populated correctly with the physical meta name. Okay, so that looks good. You could just say something like physical populate new index for technical spaces. Right, so now then, now that we do have this new index, it seems to exist, what we then need to do is we need to go back to our physical model production. So what transform were we in? So we start to lose track a little bit what we're trying to do. So in the physical model, we were trying to populate. Actually, to be honest, it's more like when we the projector. In the projector, we need to before we add that to the region, it's all provenance related stuff, so we need something like this. So is there a meta model? Presumably there is, because we have an index, so there must be already an index. We must be looping through the meta names. Where do we get those? I.second. Where do we get the I? Okay, from IN. So if I just say IN, so let's just call technical space for archetype this guy here, and then so we can just say populate technical space, something like this, and then if we just say something like const auto, I'm not sure where we are in terms of finds, but I'm gonna go for J, and if we just say something like PM ID, and if J is, well, if it's equals to the end, then we have a problem. Presumably that's also a problem here. It's actually not an error, so fine. This is a new one. But it is an error for the case of technical space, because we do expect everyone to have one of them. And so if you say something like missing archetype, and we call that the PM ID, the value. Right, then, so this guy is now going to say, well, I expect your archetype to exist. So, technical space index, something like this, just sufficient to let us know what the problem is. And then if we then say, if we did find it, then we can do something like archetype.technical space is equal to the J of the second. And that should now finally give us what we're looking for. Not quite what we had in mind, but that doesn't really matter. Okay, so what we should do now is we should now have archetypes populated from artifacts populated from archetypes, which were themselves populated from the generation of the PMM. Slightly confusing, but we're also reaching the 1.5 hours mark, so that's good. Didn't complain, everyone's happy. So we should be able to say orchestration, populate technical spaces, space in artifact from index when projecting. So okay, so at this point in time we are doing all the right things. Cosmetic fixes to identification model, and we are doing all the right things at this point in time. So finally we should be able to go back to our legacy path transform. Sorry, legacy but not path, legacy dependencies transform, and eventually we finally should be able to, after a long drawn out process, we should be able to now say, oh, by the way, archetype and if we just use the technical space, there we are, we should now be able to say so if the technical space is that, do this. Now what is going on here though? Builder is const, so I don't think that helps. And then a technical space and do this. Of course, could make this a little bit more readable. As follows, so if I just say const auto ts is this guy, and then if I say ts is equal to all of that, builder adds this user, else if ts is whatever. I mean, of course you can see we should probably really check for all other permutations, but we're not, but that's fine. And then the region. Alright, so now then, so finally we managed to populate the headers. However, so what is missing now? So we're basically saying if we recognize the chap that we're populating, and if that guy is this guy, which is good, then we get the technical space of the artifact, we inject a couple of headers into the builder will produce some kind of output. Now the problem we have is the outputs will have to be placed in the region. Well, in fact, not in the region, let's be very precise here, in the artifact. So we need some place in the artifact. This has been quite complicated, so we need some place in the artifact, path properties presumably, or is there another one for dependencies? No, it's path properties, so it's called path properties, correct? So then, path properties dot dependencies is equal to whatever the builder builds, and that is clearly okay. So wow, now what is not quite right here? So as you can see, we never, oh yes, but that's correct, because we don't actually need the archetype particularly. We just need to know it's of this type. It's just dispatching on the type, but we don't particularly care. We don't read any properties from it. Okay, I mean, we should really have something else for that, but there you go. Now, what I'd like to see is to see this thing running without breaking the world. So because this is actually doing something now. So of course the legacy transform is also kicking in right now, so it will be overwriting whatever value put in the container, so it doesn't really matter. But provided we don't break anything here, we've achieved something. And since we are close to an hour and 9:30, we should probably call it a day now as well. Let's have a look. Yeah, so that's good. So we should say something like orchestration, populate, inclusion, dependencies for archetypes. Okay, and so that is actually quite a success. I mean, obviously we would never have thought this would be this complicated, but there you are. It's always like that. Nothing is ever easy. So then what we've done then is, after quite a long convoluted path, we figured out what was missing in the logical, well, in the model that we needed to get the property. We propagated the property all the way up to the point where we're running this transform, and then we use the value for that property to dispatch to the correct place. So given that we already are in an hour and 30 something minutes, we'll just stop this part here. Thanks for watching.